Hello everyone, good morning. Good morning, good morning. Yes, so we'll start lecture number 4 of analytical geometry. So in this class, we're going to start planes, right? So in lecture number 1, 2, 3, we have finished dr and dc, right? Lecture number 1, 2, 3. Everything is based on direction, cosine, and direction ratio. So in this class, we will be starting planes, right? So I hope everyone understand dr and dc, right? That is very important to understand conceptually planes and straight lines, right? So planes, I will try to finish that in maximum by 3 lectures, right? Maximum in 3 lectures, I'll be finishing planes also. And I have given you the list of topics and previous year's question trends, right? So go through that. We will do all PVQs also, right? In planes. Okay. So in this class, what you're going to do is this is going to be a long session, minimum 2 hours, where we will be defining what is meant by a plane, and then we will be deriving the equations of plane, and then we will do some problems, right? So very simple. You just understand what is meant by dr and dc before getting to this video, right? Okay. Yes, so first what we'll do is we will define what is meant by a plane, and then we will derive the equations of plane, right? So no doubt up to now, right? Yes, we'll give practice questions after finishing planes. Okay. So first what we'll do is we will define plane, right? Okay. So plane definition. So what is meant by a plane? A plane is a surface, right? A plane is a surface such that if you take any 2 points on the surface, the line joining those 2 points will lie on the surface. Very simple. So a plane is a surface. A plane is a surface such that such that if we take if we take if we take any 2 points if we take any 2 points on the surface, right? So we have a surface. Let us say this is our surface, right? So it is a surface such that if we take any 2 points on the surface, right? Let us take a 2 points on the surface, right? A plane is a surface such that if we take any 2 point surface, the line joining the line the line joining those 2 points also lie on the surface. Also lie on the surface. Right? Very simple. You just take any 2 point. So a plane surface, if we take any 2 point surface, the straight line joining those 2 points, uh, the straight line joining those 2 points. Right? So very simple. You just take a 2 point surface, draw a straight line. That line also lie on the surface. Then it is called plane. Right? Very simple definition. So it is a surface such that if we take any 2 points on the surface, the line joining those 2 points also lie on the surface, right? If this happens, then we say it is a plane, right? Okay. Now we're going to what we're going to do is we're going to derive the equations of plane in normal form and equation of plane in general form, right? There are only two equations of plane, three equations of plane. One is in normal form, second is in general form, third is in intercept form. So there are three equations of plane we got to derive now. Equations of plane in normal form, equation of plane in general form, equation of plane in intercept form, right? So first we will derive equation of plane in normal form. Equation of plane in normal form, right? So first we're going to derive equations of plane in normal form. What is normal? Normal is very simple, right? Any line that is perpendicular to something is called normal. So here normal means a line that is perpendicular to the plane is called normal, right? So what is normal? A line, a line that is perpendicular to the plane, right? A line that is perpendicular to plane is called normal. So first what we're going to do is we're going to derive the equations of plane in normal form. So we have a plane, right? Let us take a plane, right? Let us take a plane, right? Let us consider this plane, right? Let's call this as x-axis, call this as y-axis, call this as z-axis, right? This is some plane, because whatever any two, if I take any 2 points, the line joining those 2 points also lie on the surface, so it is a plane. Now what I'm going to do is consider a normal, right? So you just visualize this in 3D. I'm going to draw a normal, right? Consider a normal. So this is our normal. So this is our origin. This is our end, right? So this ON is perpendicular to the plane, right? So imagine like this. This is a plane. This is our ON, right? This pen is our ON, right? Imagine like this. So we have a plane. That plane is this ON. This line is perpendicular to this plane because we are drawing a normal, right? So imagine like this, right? So we have a plane. This is our plane, and we are drawing a normal which is perpendicular to this plane. This is our ON now, right? So we have a plane, we have ON. So we have ON, right? Okay. Now, uh, let ON be the normal, right? Let ON be the normal, and let us name P to be the length of ON. Length of ON, right? This P is the length of perpendicular, right? Because ON is perpendicular to the plane. So let P ON be the normal, and let P be the length of the perpendicular distance, which is ON, right? So let us assume three things now. Let ON be the normal to the plane. Let ON be the normal to the plane, and P be the length of perpendicular, and P be the length of perpendicular, and let L comma N be the direction cosine of ON, right? Let L comma N be the direction cosine of ON, right? So this has some direction cosine, right? Alpha, beta, gamma with x, y, z axis respectively. Cosine of alpha, beta, gamma is called direction cosine, right? So we have assumed three things. ON is the normal to this plane. So we have a plane, we have ON, and this as direction cosine L comma M comma N with this plane, right? Yes. The equation of plane, then the equation, of plane in normal form. Normal form is given by Lx plus My plus Nz is equal to P, right? This is the equation of plane in normal form, right? Remember this equation. Lx plus My plus Nz is equal to P, right? Lx plus My plus Nz is equal to P. This L comma M comma N is the direction cosine of the normal, and P is the length of the perpendicular, right? P be the length of the perpendicular from origin. That is length of ON is P, right? Length of ON is P. Okay. From origin to N. You have to be precise, right? From origin to N. Okay. So this is the equation of plane in normal form, right? So very simple. X comma y comma z is the locus, right? So here we are. This all these x comma y comma z will satisfy the condition that Lx plus My plus Nz is equal to P. So you just visualize this as a locus, right? So all these points inside this will satisfy that whatever x comma y comma z you take, Lx plus My plus Nz will be equal to P. So this is the set of, this is a locus for this plane, right? This is a equation of plane in normal form. Now we will derive equation of plane. See, normal form we don't often use in problem, right? So just understand the equation only. Just understand the equation only. We will be not using this in problem, right? We will be using only general form. Just understand. Just remember the equation of plane in normal form, which is Lx plus My plus Nz is equal to P. L comma M comma N is the direction cosine of the normal, and P is the length of the perpendicular. That is length of ON is P. Now we will, very important thing is equation of plane in general form, right? Equation of plane in general form. This is very important. Equation equation of plane in general form. Equation of plane in general form. So we already know what is meant by, already know the equation of in normal form, right? So we know that equation of plane, in normal form, right? In normal form is given by Lx plus My plus Nz is equal to P, where L comma M comma N is a direction cosine and P is the length of the perpendicular from origin to N. Okay, now what I'm going to do is I'm going to convert direction cosine in terms of direction ratio. We will obtain equation of plane in general form. This L comma M comma N is the direction cosine. How you find direction ratio, right? So we know L comma M comma N, right? So L comma M comma N is direction cosine. We will find, so this we know that L is A divided by root of A square plus B square plus C square. That is, if A, B, C are direction ratio, then L, M, N we know, right? We know relation between L, M, N and A, B, C. And we know M is B divided by root of A square plus B square plus C square. N is equal to C divided by root of A square plus B square plus C square, right? So we know that if ABC is direction ratio, then L comma M comma N is given by this relation. Now we will replace L, M, N in terms of this. So we will have A divided by root of A square plus B square plus C square into X, My. So By divided by root of A square plus B square plus C square plus CZ divided by root of A square plus B square plus C square is equal to P, right? Let us take root of A square plus B square plus C square outside and take to that side. So we will have AX plus BY plus CZ is equal to P into root of A square plus B square plus C square. This is some real number, right? This is going to be some real number, P into root of A square plus B square plus C square. That is going to be some real number. Let us assume this to be minus D, right? Because if I bring this to this side, we will have plus D. Instead of assuming plus D, we will assume this to be minus D, right? So therefore, if I assume this value to be minus D, we will have AX plus BY plus CZ. This is minus D, so we will have plus D is equal to 0 is the equation of plane in normal form, right? General form is the equation of plane, very important, in general form. Now what is ABC? Where ABC is the direction ratio of normal ON, where A comma B comma C is the direction ratio, very important, direction ratio of the normal ON. right? Very simple. We are just converting DC in terms of DR. We will have equation of plane in general form, right? Very, very important. Just box this. And what is this ABC? ABC is the direction ratio of the normal ON, right? So whenever if you want to know equation of plane in a general form, it is AX plus BY plus CZ plus D is equal to 0. We already know what is P, right? We already know what is P. What is P? P is the length of that normal ON. So from this we can derive the formula for P, right? Note, we have assumed that what we have assumed? We have assumed minus D to be P into root of A square plus B square plus C square. So what about P? So P will be minus D divided by root of A square plus B square plus C square. So since P is the length, we will put modulus here, right? This formula will give you the will help you to find the length of the perpendicular. So given ax plus by plus cz plus d is equal to 0, if you want to find the length of the perpendicular, you can make use of the formula. We already know all this data, right? We already know a, we already know b, we already know ax plus by plus cz. ax plus by plus cz plus d is equal to 0, right? So we already know a, b, c, we already know d. So just make use of this. You can find the length of the perpendicular, right? So put modulus here so that length will be positive. Very important formula. So if you want to, given the equation of plane in general form, if you want to find the length of the perpendicular p, you can make use of this formula because you assumed that this to be minus d, right? So both so far so clear, right? So very simple equation of plane in general form. What is plane? So it is a surface. If I take any 2 points on the surface, the line joining those 2 points completely lie on the surface. Then it is called plane. A surface will be a plane. A surface will be a plane if you take any 2 points on the surface, the line joining those 2 points completely lie on the surface. Then it is called plane. So equation of plane in normal form. So we have a plane. Draw a perpendicular. Uh, Draw a perpendicular to the plane. This is our O and this is our N. So we have a line ON. This has direction cosine L comma M comma N and P be the length of the perpendicular. And the equation of plane in normal form is Lx plus My plus Nz is equal to P. Lm is the direction cosine of that normal and P is the length of the perpendicular. That is length of ON is normal. Sorry, length of ON is P. And equation of plane in general form. So we already know normal form is Lx plus My plus Nz is equal to P. Now replace Lmn in terms of ABC, that is right in terms of direction ratio. You will have equation of plane in general form. Very important. What are this ABC? ABC is the direction ratio of the normal. Because I'm stressing this because we'll be using this in problem. So ABC is the direction ratio of the normal, and what is d? You can make use of this, right? And p is the length of the perpendicular, which you can find using this formula. As of now, no doubt, right? Okay, p is the length of the perpendicular from origin to that n. Okay, so third is equation of plane in intercept form. Equation of plane in intercept form. Intercept form. So equation of plane in intercept form. So you know what is intercept, right? So intercept means when y and z are 0, x will be some length. It is called x intercept. Y intercept means x and z are 0, y is something. Z intercept means x and y are 0, z is some number. So we're going to find equation equation of intercept form. This is very easy. This we come across in school level itself, right? So we have, right, let us draw a plane. This is our x-axis. This is our y-axis. This is our z-axis. So this is, let us call this point to be some A, call this point to be B, call this point to be C. This is our x-intercept, right? Because at this point, x is some units to the origin, to the right, and y and z are 0. Let us call this to be, let us call this distance to be A, call this distance to be B, call this distance to be C. This point will be A, comma 0, comma 0. This point will be 0, comma B, comma 0, and this point will be 0 comma 0 comma c. This is our x-intercept, this is our y-intercept, and this is our z-intercept, right? So intercept means x is something and y and z are 0. Okay, so we're going to find the equation of this plane having the intercepts a, b, c. Let a comma b comma c be the x, y, z intercepts respectively. Intercepts respectively. So what is the equation of plane? So we know that equation of plane in general form is given by, see, I'm writing capital AX, right, just for a difference. Capital AX plus capital BY plus capital CZ plus D is equal to 0, because we are already using the small ABC here. Here the small ABC is the length, right? Small ABC is the length. So since I've already used small ABC, here I'm using capital ABC. Here capital ABC is the direction ratio of normal ON. I don't want to confuse this ABC with this ABC. This ABC is the length from O to this, O to this, O to this. This ABC is the length of the normal ON. Okay. Now these 3 points lie on this. Yes or no? These 3 points lie on the surface, lie on the plane. That means it will satisfy this equation, right? So we have A point. So A is A comma 0 comma 0 lie on the first plane. That means it will satisfy this equation, right? A into capital A plus B into 0, C into 0 plus D is equal to 0. So we have capital A to be equal to minus D by A, right? This will be 0, this will be 0. So D is equal to, sorry, capital A is equal to minus D divided by small a. Now similarly we have B point 0 comma B comma 0 lie on equation number 1. So we have A into 0 plus B into B plus C into 0 plus D is equal to 0. So we have capital B is equal to minus D divided by B, and similarly we have the C point 0 comma 0 comma C lie on 1. So we have A into 0 plus B into 0, C into C plus D is equal to 0. So we have capital C is equal to minus D divided by small c. So we will replace this ABC here, right? We will replace, substitute in 1, right? So we know ABC, right? Substitute capital ABC value in 1. So capital AX plus capital BY plus capital DZ plus D is equal to 0. So AX, B, capital A, capital B, capital C. You just substitute. So capital A is minus D by A. Capital B is minus D by A into X minus dx by B minus dx C dy dz plus dc, right? So I'm just uh, we just put a to be minus d by a x, b to be minus d by b y, c to be minus d by c z, right? Just a minute. Okay, now we take this d to that side, so we have minus minus dx by a minus dy by b minus dz by c is equal to minus d. Now take minus d common here, and minus d minus d minus d minus d. So we have x by a plus y by b plus z by c is equal to 1. So this is the equation of plane in intercept form where a, b, c are intercepts, right? Where a, b, c are intercepts, right? We have ax plus by plus cz plus d is equal to 0. Is it clear? So we have derived the formula for equation of plane in normal form, general form, and intercept form. Here a, b, c are intercepts, right? Let a comma b comma c be the x y z intercepts respectively. It has to be small a comma b comma c. The x y z respectively. We know that the equation of in general form is ax plus by plus z plus z equals 0. Substituting all 3 points, we are getting a b c. Substitute in 1, yes. So this is the equation of plane in intercept form, right? Okay. Now to reduce general equation to normal form, fourth. To reduce general form to normal form. Very simple, right? How you that is, if you know general form, how will you find equation in normal form, right? If you know general form is ax plus by plus cz plus d is equal to 0. You want to find that in normal form, lx plus my plus nz plus d is equal to 0 is equal to p. How to find? So general form is ax plus by plus cz plus d is equal to 0. Normal form is lx plus my plus nz is equal to p, right? Lx plus my plus nz is equal to p. So to reduce general equation, that is from general we need to convert to normal form. How you will do? What you have to do? Very simple, right? So from this we have ax plus by plus cz is equal to minus d, right? Cz is equal to minus d. Now you just have to divide by, see, you just have to divide by, that is means, okay. Just a minute. What is p? P is the length of the perpendicular ON, and we all know the formula for P, right? So P is minus D divided by root of A square plus B square plus C square. So what you can do is you divide by plus or minus 1 divided by root of A square plus B square plus C square, right? You need to divide by this, right? Why? You can divide either by plus by 1 divided by root of a square plus b square plus c square, or minus 1 divided by root of a square plus b square plus c square. You need to divide accordingly so that your p is positive, right? You need to divide accordingly so that your p is positive, because p is a length, right? So you just divide by plus 1 by root of a square plus b square plus c square, or minus 1 divided by root of a square plus b square plus c square. so that your P is positive. So if I do this, we will have plus or minus 1 divided by root of a square plus b square plus c square ax, right? Ax plus or minus by divided by root of a square plus b square plus c square. Uh, just understand this concept. We will not be using this problem, right? So you just have to divide by 1 divided by root of a square plus b square plus c square, or minus 1 divided by root of a square plus b square plus c square. Right? So therefore we have a by root of a square plus b square is, that is nothing but L, and m is b divided by root of a square plus b square plus c square. So which is in right? See, if this d is positive means, if this d is positive means you divide by plus 1 by root of a square plus b square plus c square. If this d is negative means you divide minus 1 divided by root of a square plus b square plus c square. You're getting my point, right? See, this d can be positive or negative. Whatever you just transform this d to that side. If this is negative means this will be positive. If this is positive means this will be negative. If this is negative means you divide by minus 1 divided by root of a square plus b square plus c square. Right? So that will be plus. This is nothing but p. Right? If it is positive, if it is negative means you divide by minus 1 divided by root of a square plus b square plus c square. If it is positive means you divide by plus 1 by root of a square plus b square plus c square. So which is the which is the equation of plane, which is the equation of plane in normal form. So we have did four parts. So first is equation. We have defined equation of plane. So it is a surface such that if you take any 2 points, the line joining those 2 points lie on the surface. Equation of plane in normal form is, see, I'm repeating the same often and often, right? So that so that you can understand the concept very easily. That is why only I'm repeating, right? Whenever you are studying, this will be very easy for you. We already completed DC and TR, right? Those three lectures, it will be very easy for you to follow because I'm repeating and recalling often, so that you are I'm just reducing your time, right? You can easily study this. See, now itself you can derive all these three equations, right? Lx plus my plus nz is equal to p, ax plus by plus cz plus d is equal to 0, and this is the equation of an intercept form. And to find general form to normal form, you have to do like this. Okay. Now, fifth equation. So this is equation of plane passing through a point and perpendicular to given line. Very, very important. Equation of plane passing through a point. Passing it has to pass through one point and perpendicular to given line. See, you can easily derive all these equations. You can easily derive all these equations, right? So we need to find an equation of plane. That plane has to pass through a point and it has to be perpendicular to given line. So we have an equation. We need to find an equation of plane, and this plane has to pass through this point. Let us call this point to be P, and it has to be perpendicular to given line, right? So let the given line be L. Let the given line be L, and a point be P. So we need to find this equation of plane. This plane has to pass through a point P. Pass through a point P means that P has to be in this plane, and it has to be perpendicular to the given line be L, right? So let P be the point. Just a minute. Getting a lot of notification. Okay. So let P be the point, the plane is passing through. The plane is passing through. So let us take that P point to be x1, y1, z1, right? And L be the line, and L be the line that is perpendicular to the plane, right? That L be the line that is perpendicular to the plane. Okay. Now let us assume, let the direction cosine of L be L comma M comma N, right? Let us assume that this has a direction cosine L comma M comma N. Now let us take an arbitrary point. Let us take a point A, any arbitrary point on the plane. I'm just taking an arbitrary point P A. I'm just taking an arbitrary point A on the plane, right? And you just take any point A. Let us call this P x comma y comma z, and this point is x1, y1, z1. Now draw a line AP. This line will lie on the plane by the definition, right? Because this is surface, since this is a plane, any if I join any two points by a line, that line will also that line will also lie on the surface. That is the definition of plane. Therefore, this line will be on the plane itself, right? Now L is perpendicular to the plane. See, we have a plane and L is perpendicular to the plane. That means, can I say this AP is perpendicular to L? L is perpendicular to whole plane. Here I am taking a line in the plane. This line also lie on the plane only. Can I say this L is perpendicular to AP? L is perpendicular to plane itself. And this AP is on the plane only. That means, can I say, so draw a line AP. So clearly the line L is perpendicular to AP. I don't want to write the explanation, right? This L is perpendicular to the plane. That means it will be perpendicular to AP also. That line L will be perpendicular to AP also, right? Now this P point is what? This P point is x1, y1, z1. So L is perpendicular to AP, right? Now what is the direction ratio of okay, so let L comma N be the direction cosine. Okay, what we'll do is we will prove this in terms of direction ratio, right? Because if I want to prove this in terms of direction cosine means I need to divide by its magnitude. So let us change. Let dr let let the direction cosine of L be, let the direction ratio of L be a comma b comma c, right? Let us assume that this has a direction ratio a comma b comma c, right? I will derive this in terms of direction ratio, right? So let this as direction ratio a comma b comma c, right? Now these two are perpendicular. Now what is direction ratio of what is the direction ratio of L? It is a comma b comma c. What is the direction ratio of AP? Direction ratio of L is a comma b comma c. And what is direction ratio of AP? It is nothing but x minus x1, y minus y1, z minus z1. See, if I prove in terms of direction cosine means I need to divide by its length AP. I don't want that, right? X minus x1, y minus y1, z minus z1. So we know direction ratio of L, direction ratio of AP, and they are perpendicular. That means A1 plus A1 A2 plus B1 B2 plus C1 C2 is 0. So that means A into x minus x1, B into y minus y1, C into z minus z1 is equal to 0. So this is the required equation of plane passing through a point and perpendicular to given line. The given line has direction ratio a comma b comma c, and x1 y1 z1 is the point it is passing through, right? So passing through a point, and this point is x1 y1 z1 and perpendicular to given line, and this given line has direction ratio a comma b comma c. Then this is the equation of plane passing through a point and perpendicular to given line. Is this clear? Very important, right? Very, very important. Okay. Now, very important notice, equation of plane. Very, very important note, right? Yeah. Write it next page. Equation of plane passing through a point only. Equation of plane passing through a point. Let us say that point is x1 y1 z1, right? In the previous case we have an equation of plane passing through a point as well as it is perpendicular to some line, but here equation of plane passing through a point only. See, the same is given by a same equation only, is given by a into x minus x1 b into y minus y1 plus c into z minus z1 is equal to 0. The same equation only, but in this case ABC is the direction ratio of a line that is given. Here you need to take ABC as, here ABC is the direction ratio of the normal, that's it, of the normal. Here this need not be normal, plane that is passing through and perpendicular to given line. It can be any line, but if they say it is passing through a point only means write the same equation. The only difference is, so you just take, we already know, you just take that L to be ON here. Here L is anything. Here in this case you just take L to be the ON. That is, you just take L to be the normal. Then this is the same equation. If it is any line means you take that line direction ratio. If they have been given any line means you just take direction ratio of normal. Very, very, very important. 5 and 6 are. Is this clear? Is it clear? Equation of plane passing through a point means same. See, both are same equations. If they give a line means take direction ratio of this line. If they haven't given any line means you just take direction ratio of the normal. Right? Okay. Okay. Just two more concepts, then everything is problem only. Right? 7 and 8. Equation of plane passing through 3 points. Right? Equation of plane passing through 3 points. Equation of plane passing through 3 points. So very easy, right? We need to find the equation of plane. That plane has to pass through 3 points. In the previous problem, we know equation of plane passing through single point, which is a into x minus x1, b into y minus y1, c z minus z1 is equal to 0, where x1, y1, z1 is the point that it is passing through. Right here, this plane is passing through 3 points. So we need to find the equation of plane. So we know that what is the equation of plane in general form? We know that equation of plane in general form. in general form is given by ax plus by plus cz plus d is equal to 0, where ABC is the direction ratio of the normal, right? So here this plane has to pass through 3 points. So it is passing through 3 points. That means all these 3 points will lie on the surface, right? So let A comma B comma C be the 3 points that plane is passing through. Let A comma let A, let us call this to be x1, y1, z1. B is x2, y2, z2. Let us take these 3 points to be A, B, C. Let these 3 points be. Now we can see all these points will lie on the plane. That means these 3 points will satisfy this condition, right? That means we have ax1 plus by1 plus cz1 plus d is equal to 0. ax2 plus by2 plus cz2 plus d is equal to 0. ax3 by3 cz3 plus d is equal to 0. So we need to solve these three equations to get the value of, sorry, we need to solve this equation to get the equation of plane passing through 3 points, right? That means we need to eliminate ABCD, right? So eliminate ABCD, you will get the equation of plane. So eliminating ABCD, we get the equation of plane passing through 3 points. So you can eliminate easily by matrix method. So the required equation is the required equation is given by determinant of 1 no xyz1. So the given equation, the required equation is xyz1, x1 y1 z1 1, x2 y2 z2 1, x3 y3 z3 1 is equal to 0. So if you want to find the equation of plane passing through 3 points, you just have to expand this 4 cross 4 determinant, right? Uh, if you want to find the equation of plane passing through 3 points, remember this formula xyz1, x1 y1 z1, x2 y2 z2, x3 y3 z3 is the given the 3 points that it is passing through. You just have to expand this 4 cross 4 determinant. You will get the equation of plane passing through 3 points, right? So last is uh, e condition for 4 points to be coplanar. Condition for 4 points to be coplanar. If coplanar means all 4 points lie on the same plane. Oh, very simple, right? See, already we know equation of plane passing through 3 points. Here you need to say 4 points are coplanar. So if you want to prove 4 points are coplanar, you just find equation of plane passing through 3 points. Here you have 4 points, right? You just find equation of plane passing through 3 points. See, we have 4 points here, right? A, B, C, D, right? Now find equation of plane. Find equation of plane passing through 3 points. You can take any 3 points. Just take A, B, C. Right? Just take first 3 points. Equation of plane passing through 3 points. Let us say A, comma B, comma C. So find the equation of plane passing through 3 points by this formula. That is x, y, z1, x1, y1, z1 1, x2, y2, z2 1, x3, y3, z3 1. This is the equation of plane passing through 3 points. Now substitute the fourth point in this equation. If it satisfies means the fourth point also in the plane. Yes or no? See, just find equation of plane passing through uh, 3 points. You will have an equation in terms of x, y, z only, because x these all are numbers. X, y, z is variable. So you will have an equation in the form ax plus by plus cz plus d is equal to 0. Now substitute this d point in this equation. If it is satisfied, it means that point also lie in this. That means that is same as saying it is coplanar. That is, or you can substitute this d point directly here. Substitute this d point directly here. So instead of x, y, z, you substitute the d point. If the determinant is 0, then we say 4 points are coplanar, right? So this is same as R determinant of x1, y1, z1, 1, x2, y2, z2, 1, x3, y3, z3, 1, x4, y4, z4, 1 is equal to 0. Both are same only, right? So remember this formula. See, I'm substituting this d point here. D point is x4, y4, z4. I'm interchanging the columns. It doesn't affect the value. Is it clear? You can either find equation of plane passing through 3 points, and you can substitute the fourth point in the equation. If it is 0 means that point also lie in that surface, so that means it will be coplanar. If not, you just expand this determinant. If it is equal to 0 means, then you can say it is coplanar. Is all 8 concepts are clear? Is all 8 concepts are clear? We're going to do some problems based on these 8 concepts. Okay, first is we have defined equation of plane, and equation of plane in a normal form, equation of plane in a general form, uh, and then equation of plane in intercept form, and how to convert general form to normal form, equation of plane passing through a point and perpendicular to a line, equation of plane passing through a point alone, which is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0, and condition for 3 points to lie on the plane and coplanar. Right? Just take a 2 minutes break. We will continue. We will do problems based on this. Let us have a 2 minutes break now. We'll have a 2 minutes break. After that, we will continue. We're going to do 5 problems based on these 8 equations. After that, we will be after that we will be moving on to next concepts. Okay, so problem one. Reduce reduce the equation of plane. Reduce the equation of plane x plus 2y minus 2z minus 9 is equal to 0 to the normal form. To the normal form, and hence find the and hence and hence find the length of the perpendicular from origin to given plane. Right, very simple problem. We'll do this quickly. So we need to reduce this to normal form. So that is, we need to convert general form to normal form. After that, we need to find the equation of, that is, we need to find the length of the perpendicular. Right, so we need to find, they are given this equation of plane in normal form. So solution. So we have x plus 2y minus 2z is equal to 9. So this d is positive. So you divide by plus 1 by root of a square plus b square plus c square. So divide by plus 1 divided by root of a square plus b square plus c square. What is ABC here? It is 1, 2 minus 2. So 1 divided by root of 1 plus 4 plus 4. So it is 1 by 3. So we have to divide by 1 by 3. So we have x by 3 plus 2y by 3 minus 2z by 3 is equal to 9 by 3. X by 3, 2y by 3 minus 2z by 3 is equal to. So this is the equation of plane in normal form. So we have Lx plus My plus Nz is equal to P, right? So Lx plus My plus Nz is equal to P, and this is the length of the perpendicular from origin to the plane, right? Which is a required equation. And this is the length of perpendicular, right? Because it is of the form Lx plus My plus Nz is equal to P, and P is the length of the perpendicular, right? Lmn is a direction cosine. So we are dividing by its magnitude so that it will become direction cosine, right? Very simple problem. So we'll move on to next problem. Problem number 2. If this d is if this point is negative, means you divide minus 1 divided by root of a square plus b square plus c square. Okay, so problem 2. So a plane meets a coordinate axis. A plane meets the coordinate axis. A plane meets the coordinate axis in ABC in A, B, C respectively, such that the centroid of the triangle such that the centroid of the triangle ABC is C, Q, R. So given that the center of a triangle coordinate is P comma Q comma R. Show that the equation of plane is show that the equation of plane is show that the equation of plane is given by x by p plus y by q plus z by r equal to 3. Right? Very simple problem. So a variable plane, a plane meets the coordinate axis in a comma b comma c. That is, given it is intercepts, right? So a plane, that is, it's nothing but intercepts. Intercepts. A plane meets the coordinate axis at a, b, c respectively. So let the coordinate of a comma b comma c be. Let the coordinate of let the coordinates of a comma b comma c be. Let us take the a coordinate to be a comma 0 comma 0, b point to be 0 comma b, c point to be 0 comma 0 comma c. Now what is the equation of this plane? What is the equation of plane having the intercepts a comma b comma c? We know, right? The equation of plane is x by a plus y by b plus z by c is equal to 1. Call this as equation number 1. Now it is given that the centroid of the triangle is P comma Q comma R, right? What is centroid? This A comma 0 comma 0, 0 comma B 0, 0 comma 0 comma C. So the centroid is nothing but the midpoint of the medians. Sorry, intersection point of medians, right? So we will have medians, right? So this is one median, this is one median, this is one median. So the midpoint of these three median is called centroid, right? The centroid. Now, what is the formula for centroid? This is the just recall 9th standard 10th standard mathematics. If x1, y1 is at 1, x2, y2 is at 2, x3, y3 is at 3 are the three vertices of a triangle, then the centroid is given by if r vertices of a triangle, then the centroid is given by x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. Okay, this is the formula for centroid. This is the basic formula, right? If x1, x2, x3, y1, y2, y3, z1, z2, z3 are the 3 points, then the centroid is given by this formula. Now, what about the centroid of ABC? What about centroid of ABC? See, this is a general formula. Instead of x1, y1, z1, x2, y2, z2, x3, y3, z3, we have a0, 0, 0, b0, 0, 0, c. So, what is centroid of ABC? So, it is nothing but a plus 0 plus 0 by 3, a plus 0 plus 0 by 3, 0 plus b plus 0 by 3, 0 plus 0 plus c divided by 3, and it is given that the centroid is P comma Q comma R, right? So we have equate this. So we have a by 3 to be equal to P, b by 3 is equal to Q, c by 3 is equal to R. So we have a to be 3P, b to be 3Q, c to be 3 times R. Now substitute ABC in 1, you will get the required answer, right? Write it down here. Substitute A, B, C in 1. So we have x by A plus y by b plus z by c is equal to 1. A is 3p, b is 3q, c is 3 times r is equal to 1. Take 1 by 3 outside and bring that side. So we have x by p plus y by q plus z by r is equal to 3. This is what we need to prove. A plane meets the coordinate axis in a comma b comma c such that the centroid of the triangle is p comma q comma r. Very simple. That is a by 3 comma b by 3 comma c by 3 is the centroid of this abc, and that is equal to pqr. See, you just have to you just see this and this, right? If I find ABC in terms of my aim is we need to find ABC in terms of PQR, right? We need to find we will find ABC in terms of PQR because we need to prove this. But here we have ABC, so my aim is to convert this ABC in terms of PQR. How I can do? We know that the centroid of the triangle is P comma Q comma R. So make use of the centroid of triangle ABC formula. We can find the value of ABC in terms of PQR. Substitute back here, you will get the required answer. Right? Okay. So move on to problem number 3. Find the equation of plane and the equation of plane perpendicular to the line segment perpendicular to line segment from at the middle point of the question seems to be slightly tricky, but it is very easy. We need to find the equation of plane that is perpendicular to the line segment from -3 comma 2 to 954 at the middle point of the segment, right? Okay, so very simple. So we have a line segment. That line segment has to be perpendicular. Find the equation of plane. See, very simple. We need to find the equation of a plane, right? See, first you draw a diagram, then it will be very easy for you to follow, right? Whatever question may be, draw the diagram and make use of the 8 equations which we have already proved, right? Okay. So find the equation of plane. This plane has to be perpendicular to this line segment. So we have a line segment. We have a line segment that it has to be perpendicular to that, right? Let this be line segment, right? This line segment is -3 T2 954 at the middle point of the segment, and the equation of plane at the middle point. Let this middle point be A. What is this? What we need to do? How we can find this? Very easy, right? Equation of plane passing through A and perpendicular to line. That's it. Yes or no? We need to find equation of plane passing through A and perpendicular to a line. What is the formula? A into x minus x1, b into y minus y1 plus c into z minus z1 is equal to 0. We already know that. Very simple. Right? Solution. So find the equation of plane that it is perpendicular to this line. This line is perpendicular to the plane, to line segment, and at the middle point of the segment. Okay. So that means let A be the middle point of line segment. So what is A? Let's make use of midpoint formula. So A is given by x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. So therefore A is 9 minus 3 is 6, 6 by 2 is 3, 4, 6. So 3 comma 4 comma 3 is the coordinate of A, right? Okay. Now uh, we know that equation of we know that now what about before that? So we know A. Let this be L, right? Now what about direction ratio of L? Direction ratio of L is x2 minus x1, y2 minus y1, z2 minus z1. So 9 minus half minus 3, 12, I minus 3 is 2, 4 minus 2 is 2. So this is a direction ratio. So we know direction ratio and it is passing through a point A. So therefore, we know that equation of plane passing through some x1, y1, z1 and perpendicular to the line whose direction ratio is a comma b comma c is given by a into x minus x1, b into y minus y1, c into z minus z1 is 0. So here this is our a b c, this is our x1 y1 z1. Substitute back here. So 12 into x minus x1, 2 into y minus y1, 2 into z minus z1. So we have 12x plus 2y plus 2z minus 36 minus 8 minus 6 minus 36 minus 8 minus 44 minus 6. So minus 50 is equal to 0. So this is the required equation of plane. If you want, you can take 2 outside and equate to 0. So required equation is if you want, you can take 2 outside and equate to 0, right? Or it can be 6x plus y plus z minus 25 is equal to 0. Then move on to problem number 4. The analytical geometry is very easy. If you understand the concept, just draw a diagram, memorize the equations, substitute, you will get the answer. Analytical geometry is very easy. You understand all the concepts. Okay. Okay. We'll move on to fourth problem. Find the equation of plane passing through 3 points. We are not going to do this, right? Very easy. Find the equation of plane passing through 3 points. 3 points. 0 comma 1 comma minus 1, 4 comma 5 comma 1, and 3 comma 9 comma 4. I hope everyone know how to expand a 3 cross determinant. Right? I hope everyone knows how to find the determinant of a 3 cross 3 matrix. Okay, so what is the equation of plane passing through 3 points is given by x, y, z1, x1, y1, z1, 1, 4, 5, 1, 1, 3, 9, 4, 1 is equal to 0, right? I'm not writing any story. In exam point of view, you have to write, we know equation of plane passing through 3 points is given by x, y, z1, x1, y1, z1, 1, x2, y2, z2, 1, x3, y3, z3, 1. Here x1, y1, z1, x2, y2, z2. x3, y3, z3 are given. Okay. So expand this. So you will have x into 1 minus 1 1 5 1 1 9 4 1. The second has to be minus this column, this row will get vanished. 0 minus 1 1 4 1 1 3 4 1, right, plus z into this column, this row. So 0 4 3 5 9, again minus plus minus plus minus. It has to be alternate in expand determinant. So this column, this row. So 0 4 3. So you just have to expand all these determinant. You will get some number, 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 number. That will be the required equation of plane, right? So I'll just expand only this determinant. So we have x into, so 1 into this column, this row. So 1 minus 4. In between you should have minus, right? So 1 minus 4 is minus 3. Second term should be minus, but here you should have plus 1. So 5 minus 9. 5 minus 9 is minus 4 plus 1 into 20 minus 9, which is 11. So we have x into minus 3 minus 4 plus 11. So minus 7 plus 11. So we will have 4x. Similarly, we just find all this, right? Just find all this. So you will have the equation to be, we will have the equation to be sorry, just a minute. The question is minus here. Sorry. 0 minus 1 minus 1. Sorry. See, even if it is plus means no problem, right? Just 3 points only. 0 minus 1 minus 1. Okay. This will be 10x. So the required equation is 10x minus 14y 22z minus 8 is equal to 0, right? Or to divide by 2, we will have 5x minus 7y plus 11z minus 4 is equal to 0. This is the required equation of plane, right? You just have to expand all 3 cross determinant. You will have some numbers. Multiply that, you will get you will get this equation 5x minus 7y 5x minus 7y plus 11z minus 4 is equal to 0, right? So problem number 5. So that the 4 points 0 minus 1 1 4 5 1 3 9 4 minus 4 4 4 are coplanar. So we need to show that these points are coplanar. So you can see the first 3 points are the same as the previous problem, right? The first 3 points are the same as the previous problem. So you can either you can either do expand this 4 cross 4 determinant 0 minus 1 minus 1 1 4 5 1 1 3 9 4 1 minus 4 4 1. You can either expand it, or you can do like, so method 1 is to find the equation of plane passing through 3 points. So equation of plane passing through the first 3 points 0 minus 1 minus 1 4 5 1 3 9 4. So you just find the equation of plane passing through 3 points, which we already know, which is 5x minus 7y plus 11z minus 4 is equal to 0. Now substitute the fourth point. Now substitute the fourth point minus 4 comma 4 comma 1. Sorry, 4 comma 4 comma 4. What will happen? Minus 5 into minus 4, 7 into 4, 7 into 4 minus 4, minus 20 minus 28 plus 44 minus 4. 5x minus 7y plus 11z minus 4 minus 4. Sorry, it is plus 8. The answer is 5x minus 7y plus 11z plus 4, right? Sorry, plus 4. So you will have minus 48 plus 48. So you can see this D point lie on the plane. So already 3 points lie on the plane, fourth point lie on the plane. So therefore they are coplanar. Therefore they are coplanar, right? Or you can either expand. Method 2 is determinant of x1, y1, z1, 1, x2, y2, z2, 1, x3, y3, z3, 1, x4, y4, z4, 1. You expand this and show it is equal to 0. Right? Both are same only. So is it clear? Okay, so these 5 problems are based on these 8 concepts. Now we need to introduce some more concepts in the plane. We'll move on to next concepts. Angle between the planes. Okay? Angle between the planes. Okay, very easy. So we have two planes. We need to find the angle between the two planes. So angle between the two planes is nothing but angle between the normals. Very simple. The first plane will have one normal. Second plane will have another normal. Angle between those normal is the angle between the two plane, right? So let us take two plane. We have first plane. Let us say it is a1x plus b1y plus c1z plus d1 is equal to 0. And we have second plane a2x plus b2y plus c2z plus d2 is equal to 0. So we have two planes where a1 b1 c1 is the normal of first plane, a2 b2 c2 is the a1 b1 c1 is the normal, is the direction ratio, sorry, is the direction ratio of normal, is the direction ratio of normal for the first plane, and a2 b2 c2 is the direction ratio of the normal for the second plane. So the angle between the two plane, the angle between two plane, is defined as the angle between is defined as the angle between their normals, angle between their normals, right? So this as normal, this as normal, so we know, right, what is the direction ratio. So what is the angle between the two line? If we know direction ratio, so this is the direction ratio of two normal. What is the angle? So cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 divided by root of a1 square plus b1 square plus c1 square. That is what I have said. If you understand the direction ratio and direction normal, then these are very easy to follow, right? So angle between the two planes is nothing but angle between their normals. The first plane has normal ABC and a1 b1 c1. Second plane, see, we have one plane which has normal a1 b1 c1. We have another plane which has normal a2 b2 c2. Direction ratios. Now find angle between them. Angle between the two planes is nothing but angle between their normals. So this is the formula to find angle between the two plane. Very easy. A1 b1 c1, a2 b2 c2. Apply the same formula, right? And what is the condition for perpendicular? Condition for two planes to be perpendicular. What is the condition? So theta has to be 90. So cos 90 is 0. So cross multiply it. So you will have same condition. A1 a2 plus b1 b2 plus c1 c2 is equal to 0. And what is the condition for parallel? Condition for two planes. Conditions for condition for two plane to be parallel. A1 by a2 same as same thing only, right? There, the previous topic A, B, C, A, be any line, but here the line is normal. It's clear, right? So angle between the two plane is nothing but angle between their normal. So direction ratio of the first normal is A1, B1, C1. Direction ratio of the second plane is A2, B2, C2. That is direction ratio of the normal. So apply the formula, you will get the required answer. Okay. So we're going to see three important note. Very important note. Right? We're going to see three important note. After that, we'll be doing problems and then winding off this session. Note 1. So we're going to see three very important note. All these are important problem point of view. So what note 1 says is equation of plane equation of plane equation of plane that is parallel equation of plane that is parallel to ax plus by plus cz plus d is equal to 0 is given by ax plus by plus cz plus lambda is equal to 0. Very important. So if you want to find an equation of plane that is parallel to some plane, that equation is given by ax plus by plus cz plus lambda is equal to 0, right? So what it says is, so so we have we have an equation of plane which they have given ax plus by plus cz is equal to 0. So if you want to find an equation of plane that is parallel to this plane, so if it is parallel means, so that equation is given by ax plus by plus cz plus lambda is equal to 0. You just have to replace the d by plus lambda. Very important. And you have to find the unknown lambda using some condition. They will give some condition. So we'll do that in problem point of view. Is it clear? So if you want to find an equation of plane that is parallel to the other plane, that plane is given by, you just have to replace this d by lambda. Right? This is the first note, very important note. Second important note is length of second important note is length of the perpendicular from P to the plane. Okay. So length of the perpendicular from a point to the plane. Any point from length of the perpendicular from a point x1, y1, z1 to the plane ax plus by plus cz plus d is equal to 0. So we have a point x1, y1, z1. We have a point x1, y1, z1. So we're going to find the length of this perpendicular from this point to the plane. Right? I'm just going to find this length. I'm going to find, let us say this is our point P. So length of the perpendicular from the point to the plane. Let us call this to be, you can use any notation. Let us call this to be some what number we can assign. And we assign, let us assign P, right? Let us assign P to be the length of the okay, we already assumed P to be the length of the perpendicular from origin to that plane, normal, right? So we will do what we can assign. Can assign anything. let us say it is equal to some x, right? So x is the length of the perpendicular x1, y1, z1 to the plane. Okay. So this x is given by very important formula modulus of presentation is very important. I should not change color in between. Okay. So ph. So this x is given by, so since it is distance, I'm putting modulus here. So we have ax1 plus cz1 plus d. So instead of x, let's substitute this x1, y1, z1. See, these are the one that you studied in school level itself. A square plus b square plus c square. See what happens if x1, y1, z1 turns out to be origin. You will have the very first formula. Yes or no? If x1, y1, z1 turns out to be an origin, you will have the very first formula, that is the length of the perpendicular from origin to that line will be d divided by root of a square plus b square plus c square. Just recall that. Okay. So this is node 2. Now what node 3 says is, distance between two parallel plane. Distance between two parallel plane. Getting tired, so that only I'm making mistake in writing. Distance between two parallel plane. So we're going to find the distance between two parallel plane. So we have two planes. I'm going to find distance between them. We have two planes. Right? I'm just going to find the distance between the two planes. See, you just have to visualize in 3D, right? Not in 2D. So I'm going to find distance between the two parallel plane. That is given by the formula. Just a minute. So let us say the first plane B, we have two planes. P1 is A1x plus B1y plus C1z plus D1 is equal to 0. P2 is A2x plus B2y plus C2z plus D2 is equal to 0. The distance is given by, let us call distance is equal to, that is the distance between two parallel plane is given by modulus of d1 minus d2 divided by root of a square plus b square plus c square. See, it is very simple. See, how we get this formula, don't think it is very big. So divide this separately. We have d1 by this, d2 by this. Now what is d1 by this? What is d1 divided by root of a square plus b square plus c square? That is nothing but the perpendicular distance from origin to the first plane. What is d2 divided by this? That is nothing but the perpendicular distance from origin to the second plane. Difference of that will give you, see, we have an origin, right? We have an origin. Now find the perpendicular distance from origin to the first plane. Let's call this as d1, right? Now similarly, what is formula for d1? It is modulus of ax1 plus by1 plus cz1 plus d1 divided by root of a square plus b square plus c square. Here x1, y1, z1 are 0, 0, 0. So you just apply node 2, just apply x1, y1, z1 to be 0, 0, 0. So you will have d1 divided by root of a square plus b square plus c square is the perpendicular distance from origin to first plane. Now similarly, you find the perpendicular distance Similarly, you find the perpendicular distance from origin to the second plane. Origin to the second plane. Right? Let us call this as D2. Now, what is D2? It is 0x1 plus 0y1 plus 0z1 plus D2 divided by root of a square plus b square plus c square. Now, this is the perpendicular, this is the parallel distance, right? So, overall it is D2. You have to subtract D1. That is what we are doing here, right? Overall it is D2. We are subtracting D1. You just have to visualize in 3D, right? So, it is modulus of D2 minus D1. Okay. So this is our, see, this quantity will always be positive. This quantity will always be positive. Class எடுத்துட்டு இருக்கேன் அப்புறம் பண்றேன். class எடுத்துட்டு இருக்கேன் அப்புறம் பண்றேன். So we have modulus of d1 minus d2 divided by root of a square plus b square plus c square. Right. So this is the distance between two parallel planes. These three notes are clear, right? So we're going to do problems based on this topic, angle between two planes and note 1, note 2, note 3. Find the angle between the planes 2x minus y plus z is equal to 6 and x plus y plus 2z is equal to 7. I think I know this easily, right? No sound. What is direction ratio of the first plane? 2 comma minus 1 comma 1, right? Ax plus by plus cz plus d. Don't care about d. ABC. And what is the direction ratio of the second plane? 1 comma 1 comma 2. So you know direction ratio of both the, and that is direction ratio of normal, right? You know direction ratio of both the normals. So find angle between them. So it is cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 divided by root of a square plus b square plus c square into root of so we have cos theta is equal to a1 a2 b1 b2 c1 c2 divided by root of a square plus b square plus c square a square plus b square plus c square. So we have cos theta to be 3 by 6 theta is equal to cos inverse of 1 by 2 it is 60 degree. So pi by 3 is the angle between the two lines. Planes. So angle between two planes is nothing but angle between the normals. So it will be a1 b1 c1 a2 b2 c2. Okay. Okay. Problem 7, 8, 9. All are similar problem. Very important problem. Problem 7, 8, 9. Okay. So problem 7. Find the equation of plane. Find the equation of plane passing through minus 1 comma 2 comma 4 and parallel to parallel to 2x plus 3y minus 5z plus 6 is equal to 0 from 8. Find the equation of plane parallel to 3x minus 6y minus 2z minus 4 is equal to 0 at a distance of 3 units from origin. Find the equation of plane parallel to writing question is difficult then proving the answer. And the equation of plane parallel to 2x minus 3y minus 5z plus 1 is equal to 0 and distance of 5 units from minus 1 3 comma. Okay, so these three problems are very similar problems, so we will do one by one. Okay, so you can see we need to find an equation of plane that has to pass through. So we need to find an equation of plane, right, that has to pass through this point, minus 1 comma 2 comma 4, and it has to be parallel to 2x plus 3y minus 5z plus 6. So we need to find this equation. Very simple, right? So what is the required equation is the required equation. What is the required equation? What is the equation of plane parallel to some plane? It is given by 2x plus 3y minus 5z plus lambda is equal to 0. So whatever you have, you just put plus lambda is equal to 0. This is the required equation of plane. So this equation is 2x plus 3y minus 5z plus lambda is equal to 0. Now you need to find lambda. Very simple. Minus 1 comma 2 comma 4 lies here. Minus 1 comma 2 comma 4 lie on this plane. Lie on this plane. So this is our x, y, z. We'll start with this equation. So 2 into minus 1, 3 into 2, 5 into 4 plus lambda is equal to 0. So minus 2 plus 6 minus 20 plus lambda is equal to 0. So lambda is equal to 20 minus 6 plus 2. So we have lambda to be 16. So lambda is equal to 16 is the required value of lambda. So you will get the required equation is 2x plus 3y minus 5z plus 16 is equal to 0. This is the equation of plane that is parallel to this plane as well as it is passing through that point, right? That is passing through that point. Now find the equation of plane parallel to this line at a distance of 3 units from the origin. See, we need to find lambda, right? For finding lambda, here they have given that it is passing through this point. But here they have given some other condition. Just they have given you it is because to find the value of that lambda. Okay, so solution. So the required equation is 3x minus 6y minus 2z plus lambda is equal to 0. So find the equation of plane. So you can see this has to be parallel. So 3x minus 6y minus 2z plus lambda. So we need to find an equation of this plane. Right? We need to find an equation of plane that is parallel to that line as well as it has to pass through. It has to pass it at a distance of 3 units from the origin. So it has to be at a distance of 3 units from origin. See, they have given just because to find the value of lambda. Now there is one important thing here. I'll write it down. I'll say this process. So we have so it is at a distance of 3 units from the origin. That is, they have given that perpendicular distance from 0 comma 0 comma 0 to the plane. What is the plane? 3x minus 6y minus 2z plus lambda is equal to 0 is 3, right? Now you know formula, right? So what is the perpendicular distance from point to the plane? So it is given by x is equal to 3x1 minus 6y1 minus 2z1 plus lambda divided by root of a square plus b square plus c square. So here our x1, y1, z1 are 0. We know this is 3 units. X is the distance. They are given x is 3. So 3 is equal to, this will be 0, 0, 0. So we have lambda divided by root of a square plus b square plus c square. So a is 3, b is minus 6, c is minus 2. So 3 square 9, 36, 40, it will be 7. Right? Very important now. So modulus of lambda by 7 is 3. That means lambda by 7 is equal to plus or minus 3. See, we will have we will have two planes. Yes or no? One plane is this. We will also have some other plane in the other direction, right? Even though it is in this is minus 3. This distance is minus 3. Yes or no? So we will have two planes. 3 unit means distance can be 3 or it can be minus 3 also. See, 0 to 2 distance is 2. Similarly, 0 to minus 2, this distance is also 2. So we will have two planes here, right? We will have two planes here. Okay. Is it clear? Distance of 3 units from the origin. Actually, that plane will be somewhere around here, not here. Diagram mistake. That plane will be here. Is that clear? So this plane also distance is 3. This is also 3. Maybe in the negative distance. Right? So we will have two planes. So that is why I'm putting plus or minus 3. So that means lambda can be plus or minus 21, right? Plus or minus 21. So there can be two planes. So the first plane is the required answer. The required plane is 3x 3x minus 6y minus 2z plus or minus 21 equal to 0. So there can be two possible planes. So equation of plane, so you can see two planes are parallel to this plane as well as it is at a distance of 3 units. So there are two possible planes. Is it clear? So if lambda is plus 21, we will have this P1. If lambda is minus 21, we will have this plane. So we have two planes that is parallel to this plane and also it is a distance of 3 units from the origin. Distance is 3 only, even though it is in negative direction. Right? I think I'm audible, right? Comment session is very inactive. Everything is clear, right? Audio, video. Okay, okay. Thank you, thank you. Now again, similar problem. So find the equation of plane. Find the equation of plane parallel to this plane and at a distance of 5 units from minus 131. Here 3 units from 000. So here we have same problem only 5 units from minus 131. So we need to find an equation of plane that is parallel to 2x minus 3y minus 5z plus 1 is equal to 0. It has to be parallel to some plane at a distance of 3 units from origin. So we have to find this is 2x minus 3y minus 5z plus lambda is equal to 0. This has to be at a distance of 5 units from minus 131. Similarly, you will have here also this is our minus 131. So we will have again two planes. So we need to find these two equations, right? Okay. The required equation is 2x minus 3y minus 5z plus lambda is equal to 0. Now it is at a distance of 5 units from this point. So it is at a distance of can write it directly. Write it directly, right? Okay, so um, perpendicular distance from minus 131 to the plane 2x minus 3y minus 5z plus lambda is equal to 0 is 5. So we have 5 is equal to modulus of 2x1 minus 3y1 minus 5z1 plus lambda divided by root of 4 plus 9 plus 25. So we have 5 is equal to x1, y1, z1 is minus 131 So 2 into minus 1, 3 into 3, 5 into 1 plus lambda divided by root 38. So we have this is implies 5 is equal to minus 2, minus 9, minus 11, minus 16. So we have minus 16 plus lambda by root 38. So that means minus 16 plus lambda by root 38 is equal to plus or minus 5. So that means lambda is equal to plus or minus 5 root 38 plus 16. So that means lambda can take two value. One is plus 5 root 38 plus 16. The other is minus 5 root 38 plus 16. Right. Therefore, the required equation is 2x minus 3y minus 5z plus lambda. So lambda is 16 plus or minus 5 root 38 equal to. So there are two planes, right? A distance of 5 units from minus 131. So we'll do last problem and then we'll wind off the session. Problem 10. So find the perpendicular distance between the parallel plane. Oh, sorry. This perpendicular distance between parallel planes. Sorry, right? Perpendicular distance between two parallel planes. Perpendicular distance between two parallel planes. Okay. The perpendicular distance only writes this. Find the perpendicular distance between the parallel planes. Two x minus 3y minus 6z minus 21 is equal to 0, and 2x minus 3y minus 6z. See, for parallel planes, these has to be same. Constant should only differ, right? Because it is parallel, right? It is parallel means plus lambda will only be changed. So we need to find distance between two parallel plane. So we know formula. Just apply the formula. That's it. What is formula? So distance between two parallel plane is given by modulus of d1 minus d2 divided by modulus of d1 minus d2. So d1 is the constant term in first plane. d2 is the constant term in second plane. So modulus of d1 minus d2 divided by root of a square plus b square plus c square. Now what is d1? d1 is minus 21. d2 is plus 14. And what about the value of root of a square plus b square plus c square? ABC is same for both, right? Because parallel planes only. So these three terms will remain same. This constant will only be changed. It will be root of 4 plus 9 plus 36, which is 7. Therefore, it is given by modulus of minus 21 minus 14 divided by 7. So it is 35 by 7. So it is 5 units. So always put units here, right? I forgot to put units. So okay, plain equation only. Okay. So here only you put units. So we'll finish it off here in this session. We'll continue the problems the next class, right? So today evening, you have one more class. Today evening we will have another 2 hours. So we will complete planes maximum by 3 lectures. This is lecture number 1 of plane. So in another two lectures, I'll be completing planes, right? So in this class, what we have seen is the very first we have introduced um, the definition of plane. That is, you take any 2 point, the line joining those 2 points will lie on the plane. Then it is called plane. Equation of plane in a normal form: Lx plus my plus nz is equal to p. Equation of plane in a general form: ax plus by plus cz plus d is equal to 0. Equation of plane in intercept form: x by a plus y by b plus z by c is equal to 1. And how to convert general form to normal form: equation of plane passing through a point and perpendicular to the line which has direction ratio a comma b comma c. It is given by a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. Equation of plane passing through a point: a into x minus x1 b y minus y1 plus c z minus z1. Here abc is the direction ratio of normal, right? And condition for equation of plane passing through 3 points, very easy. Condition for 4 points to be coplanar, very easy. We have solved 5 problems based on that. After that, we will use angle between the two plane. It is nothing but angle between the normals. So a1 b1 c1 is the normal of first plane. A2 b2 c2 is the direction ratio of normal of second plane. Apply cos theta formula, you will get the answer. And we have seen three important note. um, equation of plane that is parallel to some plane. You just have to replace that constant term by plus lambda. Second is length of a point from perpendicular distance from point to the plane. Modulus of ax1 plus by1 plus cz1 plus t divided by root of a square plus b square plus c square. And the note 3 is distance between two parallel planes. So based on that, we have solved another 5 problems. So next class we will be completing. We will be introducing more concepts on planes, right? So thank you. So I hope there is no doubt. Okay. So I hope there is no doubt. So in the next class we will be continuing planes, right? So thank you. All the best.